Okay, here we go. Day two. This lesson is for Friday, March 20th. There were a couple of questions that I saw were asked. Those questions pertain to the alternative definition of acids and bases, base loser, base acceptor, those types of things, and the difference between the hydronium and hydroxide ions, what that entails. I'm going to deal with the alternative definition stuff. And I'm going to start with NH3 because NH3 is like water. It can act as an acid and a base. It's amphiprotic or amphoteric. If you look at NH3, I can have two formulas for NH3 that are going to differ by an H. It could be NH4 or NH2. Let's look at that combination. Okay. I can go to NH4. That would be positive, or NH2, that would be negative. Okay, NH4 or NH2. The background's a little dark. Yesterday I did this a little later at night, and I had the darker background. Hopefully you can see it. I can sort of see it on the screen. It's not the best, but I can see it. Hopefully you will be able to. If you can't see it at all, you'll have to tell me tomorrow. But in this case, NH3 is going to act as both. If I look at NH4 here, right? NH4 and NH3, this would be a conjugate pair, right? 4 has more H's, so that would be the acid. And in this case, NH3 would be the base. If I look at the NH3 reacting to form the NH2, NH3 to NH2, 3 has more, so it's the acid, and NH2 would be the base. So the difference between an acid and its conjugate base, or a base and its conjugate acid, would be one more H, and everything else is the same. And the one with one more H is going to have one charge higher, because it's actually not just an H that gets transferred back and forth, it's the H positive. It's the hydrogen ion, which I'm going to talk about in a couple of minutes. So if I can just do one more equation, I'm going to use the NH4. NH4 positive plus Cl negative in equilibrium with NH3 plus HCl. Okay. Cl and HCl. The only difference between Cl and HCl is an H. The only difference between NH4 and NH3 is an H. So 4 is bigger than 3. That's the acid. Looking at the HCl and the Cl, HCl has one H, this has none. That's the acid. Then the other ones become bases, right? That means on each side you have one acid, one base. The other side, one acid, one base. And in each of the pairs that you made, you have one acid, one base. Okay, hydronium and hydroxide. First off, the thing getting passed back and forth is the proton. This acid loses H positive. And in the Arrhenius definition, they talk about is the proton being transferred. That's actually a lie, right? The free proton does not exist in a water solution. In a water solution, that free proton is going to attach to a water. So H positive would actually attach to H2O and then make H3O positive. This hydronium is actually the state of the proton. So we say proton, we really mean hydronium. So if you hear proton or hear hydronium, it means the same thing. It represents the ion in the Arrhenius acid system, or for that matter, the Bronsted-Lowry acid system. Right? The hydroxide, it's a lot easier. It's just OH negative. Okay? And you take a base like NaOH, you put it into water, the OH comes off, the Na remaining positive, the OH negative. That's the base ion. It's called hydroxide. And the names of these ions, both of them, hydronium and hydroxide, are on reference table, your polyatomic ion table. What is it, E? I don't remember off the top of my head right now. Pretty sure it's table E. But just go look for the table that says polyatomic ions, and you'll see hydronium. Hydronium is like the first or second. It's, upper left, and hydroxide's on the right side, more down towards the middle. Okay? So those are the answers to the questions that I've been discussing, or have been discussed with me. All right, take out your books. turn to page 189. I'm going to go over some of the questions in there. Some of them I'll read to you. Some of them I'll explain on the whiteboard if they need it. I think the part A questions are very much straightforward, so I think I can just read the question, give you a quick verbal explanation, and that might be enough. And remember, anything that you have questions on, you give me a message on Edmodo. Even during the day, every once in a while, I go on and I'll check to see who's been asking me questions. I'll respond on Edmodo, and if it requires even more than that, I'll just go on and make my little video for the next day, and I'll answer questions there too. I actually even had one student reach out to me via email. You can do that. You can email me at acastle@levittownschools.com. You can try that. I don't stay on my email all day, but I'm on and off it during the day. Don't really have too many places to go, man. I'm kind of trapped in the house like you guys, right? So I've been answering, when I get questions. Anyhow, question number 1. It says, according to the Arrhenius theory. The Arrhenius theory, that's this: the H positive acid, OH negative base. According to the Arrhenius theory, the only negative ions in an aqueous solution of a base are, it's going to be choice 1, the OH negative ions. I don't know why I'm circling it in my book. I guess so I can check to see if I got any right or wrong later. Or at least I can remember what I told you. If someone has a question and said, hey, Miss Castle, was that right? Did you make a mistake? I want to know what I told you. So that one would have been choice 1. Second one. Which statement best describes a solution produced when an Arrhenius acid is dissolved in water? You're looking for the H positive as the only ion in the solution, or the only positive ion. That would be choice 3, right? Because you put an acid in, it's H positive with Cl negative. That H positive goes into the solution as the only positive ion, and then any of the negative ions would be whatever is left. So it's the positive ion that makes it the acid. It's the negative ion which makes it a base. And both of those are the ions that exist in water. All right. Number 3, which substance can act as an acid in aqueous solutions? It would have to start with H, so that would be choice 2. Also remember that sometimes they end in COOH. That's the organic way of writing it. Organic chemistry is one of our upcoming topics. I'm going to have a lot of fun making organic videos for you. If we're still doing this, I don't know. We probably will be. I was listening to the news today, and they keep saying it's going to be long term. Anyhow, I'm beginning to enjoy this. Are you? Number 4. Unlike an acid, an aqueous solution of a base. Okay. Well, since it says solution, it's in water. In every single water solution, there are both the acid ions, whether you want to call it proton or hydronium, and the base ions, which are hydroxide, because water is really HOH. If water is neutral, pH 7, H and OH equal. If it's a basic, there's more OH. If it's acidic, there's more H. And that's based upon that pH scale where the numbers kind of add up to 14. So looking at this one, unlike an acid, an aqueous solution of a base contains more OH. The answer would be choice 4, more OH than H ions. Number 9. According to one acid-base theory, this is getting into the alternative theory, which we previously knew as the Bronsted-Lowry theory. According to one acid-base theory, a water molecule acts as an acid. All right, acids are losers or donors. Like if you take acid, you're a loser. So acids are for losers. So you're looking for a term that says or refers to losing an H, donating and losing to the species is the same, right? This donating is a nicer word, I guess. I don't know. Number 6, when a compound yields hydrogen ions, that's the H positive, okay, as the positive ion in the solution, it needs to be an acid. We need formulas for acids. Choice 3, both have formulas that start with H. And the other one there, the HC2H3O2, I know I told you this yesterday, but I'm going to highlight that once again. Just clean my board a little bit. Top part of this away. Acetic acid, which is this, HC2H3O2 or CH3COOH. I need a new marker. All right, I'm going to have to get myself another marker. But it says CH3COOH. I gave you and showed you some of those yesterday. Okay, that would have been choice 3. Number 7, what are the relative ion concentrations in an acid solution? Choice 1, more H than OH. Number 8, what color is phenolphthalein in a basic solution? You have to go to your reference table for acids and bases. When you look to phenolphthalein, I forget what the exact range is, but the high side is the base side. That's pink. Okay, so the answer, well, I was marking my answers down before. So for bases, it would be pink, choice 2. And what I say, number 7 was, can someone tell me what I said? I hope I said number 1. Okay. Acid solutions have more H ions than OH ions. Number 9, given the balanced chemical equation, according to one acid-base theory, okay, it's asking about the water, okay, you're going to have to connect the H2O to the H3O. That's your conjugate pair. They differ by an H. H3O you would label acid. H2O you would label base. Bases are the ones that steal. Bases steal. Like in baseball, you steal a base. Bases steal. All right, they don't use the word steal. Like I said, they use the nicer words, donate and accept. Stealing and accepting is basically the same thing. You can steal someone's wallet or they can donate it to you and you can accept it. The end result is you end up with a wallet. Number 10, according to one acid-base theory, an acid is a proton donor, loser, donor, same thing. That would be 4. Okay. Going to move on to the part B1 questions. Okay. Starting with number 12. Which substance is classified as a salt? All right. I'm going to look at all these choices here because we're going to learn about what things are electrolytes or not electrolytes, what acids, bases, and salts are. All right. Salts are ionic compounds. That means it has to contain metals and nonmetals. There is one exception to that. That's the NH4Cl. I remember one day someone brought it up in class. They, well, that one you said was a salt, but they're all nonmetals. That's the one exception because the NH4, that creates the ammonium polyatomic ion, which behaves metallically. So NH4Cl is ionic, even though it contains all nonmetals. Anything else that's ionic is going to contain metals and nonmetals. And again, exceptions to that are going to be your bases because bases are ionic as well, but they have the OH in it, so that's how you recognize it. So let's look at question number 12. First one says CaOH2. It has the OH group, so it's a base. It has a Ca, so it's a metal. That's a base, okay? So if you want to write that down next to choice 1, write down base. Let's look at choice 2, okay? It says C2H4OH. It's got the OH group. You're thinking, hey, that's a base. But it's got carbons and hydrogens, all nonmetals. It's not ionic. It's not a base. That's the one that's an alcohol. If it has C's and H's, if it's organic in nature, organic compounds contain predominantly carbon and hydrogen. If it contains carbon and hydrogen with the OH group, then it is an alcohol. That's not a base. As a matter of fact, it's not even an electrolyte. I believe I had said yesterday, alcohols and sugars are not electrolytes. Actually, any molecular compound, when you have two nonmetals together, except for the ammonium chloride, NH4Cl, or that ammonium ion making an ionic compound, whenever there's nonmetals, it's going to be molecular. Okay? So choice 3 is also a molecule. That's carbon tetrachloride. They used to use it for a cleaning solvent. And then the last one is CaCl2. Ca is a metal. Cl is a nonmetal. It's metals and nonmetals. It's ionic. It's not an acid or a base. All right. The salt is choice 4. That's calcium chloride. It's actually pretzel salt. Okay. Pretzel salt is calcium chloride. Right. Your table salt is sodium chloride. All right. Next one. Consider the neutralization reaction. Neutralization reactions are acid plus base gives salt and water. It says which compound is the salt. I'm going to go through all of them. H2SO4 starts with H. That's the acid. KOH ends in OH. That's the base. K2SO4. K is a metal. The SO4 polyatomic ion is composed of nonmetals, metal, nonmetal, that's ionic. It's not an acid or a base. That's your salt. So that makes your answer choice 3, K2SO4. And then the last formula is water. Right? Now let's turn the page. I'm amusing myself. Sorry, guys. Number 14, all right? The aqueous solution turns litmus red. Okay, you look at litmus and you find that it's red on the low pH side, right? You look at the two numbers. I think it's like 3 to something to like 8. Got to look at the numbers, and then it's red to blue. Red is on the lower pH side. That's the acid side, okay? So you'll need an acidic pH. So that would be 4. 4 is on the red side. Okay. Number 15, we have NaOH and HCl. This is a disguised neutralization reaction. You have to figure out what the product of the neutralization is. You take the OH off the base and the H off the acid, right? That makes your water. What are you left with? You're left with an Na and a Cl. Now, this is actually a particularly easy one because you don't have to crisscross the charges. Na is positive 1, Cl is negative 1. You don't need to worry about is it 2, is it 3, do they cancel, do they reduce? It's 1 to 1. So the answer is simple. Choice 4, NaCl. Number 16, this is the trickier one, right? Number 15 was straightforward because they're both positive 1, negative 1. Number 16, it's the same question. You have Na, and then you have the SO4. SO4 is negative 2. You got to look up the charge of the polyatomic ion. That means you're going to need 2 NAs for every SO4. So you're going to need your formula for the salt, which is going to be, the resultant will obtain, it's going to be Na2SO4. Oh, wow, this is a tricky one. All right. Your salt is going to be Na2SO4, but since H2SO4, right, has 2 H's, you're going to need twice as much of the Na. This is a limiting reagent problem. They actually don't include these on the exams anymore. But the answer would be you would have leftover H2SO4 and you would have the Na2SO4. So the answer would actually be 1, but you don't have to worry about that one. That's more difficult than you would need to do. What you would have to understand, though, is why the Na gets the 2, because the SO4 is negative 2. Right? I have people making faces at me, too, while I'm doing this. All right. Number 17. A sample of a solution has a pH of 10, and it's tested, right, with both litmus and phenolphthalein. You got to look up the litmus and phenolphthalein on reference table M. You're going to see the high pH side indicates phenolphthalein will be pink and litmus will be blue, right? So go to your reference table M, look at it, and the answer is 1. I think one good thing about this, when I do it in class, if someone has a question, I got to pause. But if you want to look stuff up, you can always pause me and keep on going. So I think for some of you, this might be working. Number 18. A student observes that an unknown solution conducts electricity. That means it's an acid, base, or salt. And it turns blue litmus paper to red. Red is the low pH side. So that would have to be an acid. Number 19. An aqueous solution of an ionic compound, that could be a base or a salt, because remember I got to show you another friend here. Come here, Harry. Come here. You want to look at my camera? I got to show you Harry. Come here. You saw Mohawk yesterday. This is Harry. Harry, say hello to everyone. Okay, good boy. All right. Sorry. An aqueous solution of an ionic compound turns red litmus to blue. Reacts with an acid to form salt and water. If it turns red to blue, blue is the high pH side for litmus, so it's going to be a base. Remember, bases have to end in OH, okay? And number 20, okay? It says, what will be the concentration of 150 milliliters of a 2.4 molar solution if it is diluted to 200 milliliters? This is an MAVA is equal to MBVB, okay? So you're going to set up your formula. Hopefully my marker works. I had it sit for a minute. It might work. Okay. MAVA is equal to MBVB. Molarity of the acid. This is actually a dilution problem, which works the same way. It's going to be 2.4 times 200. 2.4 molar times 200. And then the other side was, the other volume was 150. This was actually more along the lines of our previous topic. 150 and then X. So it would be X is equal to 2.4 times 200 over 150. So X is equal to, let's see if I can do this in my head. That's 4/3. So 24 divided by 3. It's 8. It's going to be 30. X equals, I'm thinking it's about 30. I'll have to work it out with a calculator. Look, if it's not 30, when I shut this video down, I'll tell you that the answer to question number 20 was 30 a choice. No, it must have been 3.2. 30 is not even a choice. It would have to be 3.2. But if it's not 3, I'm going to calculate it when I shut this down. I don't want to remake the video. I'll shut it down. I'll calculate the answer with a calculator. And if it's not 3.2, I will immediately announce that. But it's 3.2. Okay? Take care. I hope you enjoyed this. Bye-bye.